Hello and welcome to another video. This is another limit problem, and this would be a very easy problem if we didn't have this absolute value function embedded in a limits problem. So if only we could take care of this absolute value, then we can find the limit, because I know that if this was just 5 minus x over 5 plus x, all you have to do is replace the x with this, because this is a finite number. Just go plug in negative 5 into this and you get your answer, right? But now, because it's in an absolute value form, you don't know what you're going to do. Are you supposed to write minus x or plus x? You don't know. But this is a simple thing, because all you have to do is define what the absolute value of x is. And once you do that, the answer pops out. Let's get into the video. By definition, the absolute value of a function is either the positive or the negative. Remember, and there's a reason why this is so. But I don't want to go into the reason. I just want to show you what you should do every time you get an absolute value problem. So let's start from this side. You see, by definition, the absolute value of x is equal to either of two things. It is this. What is inside this function will be the positive x. As long as x itself is greater than 0. When x is greater than 0, that is when x is positive. So remember this in algebra, that sometimes we don't like saying x is positive. We just say x is greater than 0. And this is a better and more universal way of expressing it, in case what you have is not x, it's a function or something weird. Okay, so it's always better to write greater than 0 than to write positive. Okay, now the second option is this could be actually negative x whenever x is less than 0. Now this looks redundant. Yeah, I know that it's negative x when x is less than 0, positive x when x is greater than 0. Okay, so you tell me, this sign, so what this means, you have to know this definition. So what this means is, wherever I see absolute value of x, I must replace it with either of these two. So I have to choose x or I have to choose negative x. What would I choose in this case? Well, it tells us that x is approaching negative 5. As x approaches negative 5, is it greater than 0? No. It's approaching negative 5 means it must be less than 0. So whether it's approaching negative 5 from the left or from the right, it's a negative number. Look at the number line. When x is approaching 5 from here, it's definitely coming from negative 4. So it's coming from the right. If it's approaching negative 5 from the left, it's coming from negative 6. So it's still a negative number. So this is what you're dealing with. You're dealing with this. Therefore, as soon as you see a problem that has an absolute value function and it's as simple as this, okay, I have another video that explains when it's more complicated. But if it's this simple, you go back to the definition. What should I choose? Should I choose this or should I choose this? So I'm going to choose this lower option. So I'm going to say that this is the same thing as the limit as x goes to negative 5 of 5 minus, instead of writing this absolute value of x, I'm going to replace it with either of these, and we've decided that it's going to be the negative one because x is approaching negative 5, and from either side, whatever number that is, it will be negative. So it's the negative option, okay? Minus negative x divided by 5 plus x. You see that? And this is the same thing as the limit as x approaches negative 5 of 5 plus x over 5 plus x. Now, it would be a terrible mistake if you decide to plug in this. You don't need to plug this in as long as this simplifies. So this is the same thing as the limit as x approaches negative 5. What is this divided by this? It's 1. Well, the limit of a constant is that constant because it's not changing. So your answer is 1. See you in the next video. Never stop learning, because those who stop learning have stopped living. Bye-bye.